One more time. I'm going to draw the line through the circle. My last chance. Peter's only give me one more chance. You put this here. You have to make sure it's small enough that it's going to intersect the segment you have. I can make a mark there, and then I'm going to make a mark here. And now I'm going to open it up. That was the issue. And then I'm going to put it over here, and I'm going to draw an arc, and I'm going to move it over and draw another arc. And that's what you were looking for. And then from here, you would draw the line through right there. And that should be the line tangent. Woo! Took me a while. Sorry. Okay, next one. Okay, the next one. I'm going to be up here. And now I want to try to find the circle that passes through these 3 points. To do that, you are going to draw a segment from one of the points to the other point. You are going to find the perpendicular bisector. Remember, your perpendicular bisector, you first have to make sure this opening is over half. So do you agree that this is over half the distance? Okay. And you want to draw an arc above the line. You also want to draw an arc below the line. Move the needle without moving the opening of your compass to this one over here. You want to intersect the arc that you made and the other one. And now you can draw your line. Make sure you draw it long enough because you're trying to find the center of the circle. So make sure you draw it fairly large. I wish there was oh, there's the undo button. Oh, look it. Now it did the whole thing. What in the world did it do? Oh, it turned it. That's not what I wanted. I thought that was an undo. Anybody see on this screen where I could undo? I guess not. Okay, now the next line, I would connect the other two. I do the same thing. I have to find the perpendicular bisector of this line. Make sure you're a little bit over half. Draw an arc above and below the line. Flip the needle. Same thing. Then you are going to draw the line through this and make sure it intersects the other line. Then you're going to put the needle on the center that you found. You're going to open up your compass to one of the points, and then you are going to go ahead and spin it around. And it should go through the 3 points. Mine's a little bit off. I can do this with a, I didn't want to do that. I can do this with a hand compass. So much better. You done? By your tables, like you should have had your test. Oh, now I'm going to erase all of this. I need to play with this a little bit more, I think. Okay, what did we learn yesterday? Okay, so the arc length. Let me find my pen. Oh, I didn't. Okay. Um, this is your circumference formula, which is 2 pi r, but then I'm going to multiply it by the arc that they're talking about, that degree, over 360. So what's the radius? 13. The degree is 225 over 360. Remember, I showed you how to get a hold of that graphing calculator on your phone. It is TI 84 calc.com. Go ahead and look that up because you want it to be able to reduce your fractions, unless you want to do it by hand. That's fine, but a lot of you aren't good with your math facts. So if you start it, it looks just like my graphing calculator, right? So we are going to multiply we're not going to multiply the pi. We're going to keep this as an exact answer. So the pi is just going to be part of the answer. This is all part of the numerator. So we're going to multiply 2 times 13 times 225 and press enter, right? And now you're going to divide that by 360. But we want this as, this is the decimal. We're going to give it the improper fraction. So hit math, enter, enter, and it's 65 pi over 4, right? Did we get that from yesterday? Can I move on? I have a lot of people talking. Do you have a question on this that I can help you with? Or do I need to show you how to do something? Okay, so now I'm going to go to the next. the measure of the arc or central angle indicated, assume the lines which appear to be diameters are actually diameters. So GD looks like a diameter. Do you all agree with that? And if GD is a diameter, also HE is a diameter. What do diameters do? It cuts it in half. So this side should be 180 degrees. This side should also be what? 180. So it's asking for arc GF, right? So if I also know that this is a diameter, is there a way to find ED? 180 minus what? 115. And what is that answer? 65. Okay, now it's saying I need GF. But I also know what? That this is another diameter, right? So this half also has to equal 180, right? So if I take 65 plus 46, which would be, what is that, 110? Oh, 111. Why did I think okay, I was looking at that before. Now just subtract it from 180. And what is that, 69? This would actually equal 69 then. So, and the measure of arc GF is equal to 69 degrees. So this was a two-step problem because I didn't have enough information to find GF by itself. But I knew that I have two diameters. So if I found the key to these is it's like a puzzle. Has anybody here ever done Sudoku puzzles? Yeah? No? Okay. If you ever done any type of math puzzle, the first thing you want to do is to mark and find out anything you can first. Because you may not have a plan up front, but once you start marking the individual pieces, it will come together eventually, right? This is the part of geometry that makes it your critical thinking class. It's called quantitative reasoning skills. And so I can't just give you a formula. I can't just give you steps. All I can tell you is look for diameters. Remember, it cuts circles in half. You know central angles are the same as the arcs it intersects, and mark what you know around the circle. And then from there, it will lead you to the answer. Does everybody understand that? Okay. This is the type of stuff my mom brought home as a welder. She'd have to do all these little markings and stuff. So the trade skills do this type of stuff all the time. You're given some pieces of information, you know it may be a circle, and from there you gather more information. Okay. So here it says find the length segment of each indicator. Round your answer to the nearest tenth if necessary. So when it's talking about 4.8, 4.8 is this piece right here. Okay? And 10.2 is this piece over here. What type of shape is this? Triangle. And since it's a triangle, and it's a right angle right here, What could I use to find the missing side of a right triangle? Yep, a squared plus b squared equals c squared. This is your hypotenuse here. That's C. These would be your A and B, right? And I could call this 4.8. So it would be 4.8 squared plus B squared is equal to 10.2 squared. So I turn this on. I do 4.8 squared, which is 23.04 plus b squared equals, what's 10.2 squared? What is it? 104.04. I'm going to have to subtract because they're on opposite sides of the equal sign. That would be 0 here, right? Or I can just subtract it here. 104.04 minus 23.04 is equal to 81. Oh, that makes it easy. Because what's the square root of 81? 9. Now, for those who are going into Algebra 2, for those who are going to Math 136, when you take the square root of both sides, technically you get two answers. But we throw out the negative because in geometry you can't have a negative side length. But I don't want anybody going to Mr. Adams saying that she didn't show the negative, right? And I have it recorded. So don't lie because I can pull it up. Okay? So now, find the measure of the arc or angle indicated. So, what? This is an inscribed angle. What's the relationship of an inscribed angle? Multiply by 2. So this over here, this arc KL is equal to 64 times 2. Now, I want you to take a look. This is an inscribed angle, so you multiply it by 2. But when we looked at this one, they were exactly equal, right? That the central angle, this angle here, right here, is equal to this one. When it's coming off the center, remember it's equal. When it's on the circle, this is inscribed angle, so we would have to multiply by 2. Let's see, what did that be, 128? Okay, is that the answer? Was that what they were looking for? No, because really they are looking for arc MK. But because I labeled this piece, now I can do the next. Because what does a full circle have to equal? 360 degrees. So 360 minus 128 minus 119 would give you arc MK. The measure of arc MK. And what was that equal? 113. Hey, Michelle, did you take the surface area volume test? Okay, they are having orientation on Friday, so no teacher is going to be available. I am not going to be here on Friday anyway. So, what? How many classes do you have? Do you have all 4 class periods? Are you able to stay 4th period? Okay, you can just pop in my 4th period class and do it. Okay, so yesterday I gave you some formulas, right? It was in your note. It wasn't, you have the notes from last week. It was a continuation of those notes. If, if the, if the vertex is on the outside like this one, right? Angle ECF would equal these two subtracted, and it'd be half. So how I would write that would be 3x is equal to 1 half 115 minus 55. Isn't that what we did last time? Okay. So I would do, and I'm trying to solve for x. So what's 155 minus 55? Or no, 115 minus 55, sorry. 115 minus 55 is 60. And I need half of that. Half of 60, 3x. So 3x would equal 30. What would x equal? 10. And I think that's all they asked. Solve for x. Now, does anybody remember the relationship? If it was on the inside, it had a different relationship. Well, it's still by 2, but I add this time. I don't subtract. Right? I'm going to change that color because that green is hard to see. So x plus 80, this inside angle here, would equal 1 half, but this time you add the two arcs. Right? So I'm going to write it a little bit over here because that's hard to read. I'm going to simplify 1 half x plus what, 160? Okay, at this point, I could distribute the half, but it's actually easier just to multiply by 2 on both sides. Or I could distribute the half. Well, how do you want me to do it? You want to multiply by 2? So if I multiply this side by 2, I have to multiply this whole quantity by 2 here. That's just so I'm not dealing with fractions. What's 2 times x? 2x. 2 times 180? 160 has to equal x plus 160 because that's multiplying by 2 canceled out the half. Oh, we get x is equal to 0, by the way, because when we subtract 160 and subtract, we just get x is equal to 0. Okay. Is that the last one? No. Oh, next page. Okay. Okay, this time it's on the circle. So this is just another version of an inscribed angle, right? So what's the relationship between these two? What am I going to multiply 2 by? 95. There you go. Equals 23x plus 6. So this would be what, 190? Equals 23x plus 6. Subtract 6. 23x is equal to 184. Divide by 23. X is equal to, what is it? 8. Thank you very much. And what, it was just to solve for x was the directions, correct? Okay, and then this one was the formula we learned yesterday, which is wanting area. So area formula for a circle is pi r squared. However, we're not doing the total area, we're doing a partial area. So that'd be 285 over 360. So pi times 13 squared, 285 over 360. So pi, what's 13 times 13? 169? Is that right? Yeah, I was right. So pi times 169 times 285. Let me make those look like multiply. Divided by 360. We're going to keep it as exact answers. 269 times 285. Press enter. Divide by 360. And then I'm going to hit math, enter to change it to an improper. Oh, that's an ugly improper fraction. But that's what it is. 3211 pi over 24. Okay, how do I prove if something's tangent if something's tangent or not? What am I going to do here? Yeah, you're trying to see if this is a right angle. The only way this is a right angle is by using the converse of the Pythagorean theorem. So this would be your C, A, and B, because C is always a cross. And we're just going to check to see if it's equal. If it's equal, it's tangent. If it's not equal, then we say not tangent. There we go. So 9.9 squared plus 13 squared, does it equals 16.5 squared? So 9.9 x squared plus 13x squared is equal to 267.01. And now we're checking to see the other one. 16.5 x squared. Are they equal? No. So this is not tangent. Okay, to find the perimeter, you cannot just divide by 2 on these. You have to actually walk around to find the missing pieces. We can find this one fairly easily. If this is 8, what's this over here? This one's 8. If this little piece here is 6.8, how would I find this piece over here? Yes. 13.4 minus 6.8 will give me this missing piece. 6.6. Thank you, Andrew. 6.6. And so then what's this piece over here? 6.6. Now you add the outsides. Add all of those. You would not add the 6.6. Am I missing something? Oh, we are missing a little piece here. No. Okay. If this is 6.8, this is also 6.8. So subtract these two. What's 9.7 minus 6.8? So this little piece is 2.9. So this piece over here is 2.9. Thank you for your good eyes. I missed that little piece. You'd have to add all the circle. Who had the good eyes? Was it Peter or was it Mon? So who gets the sucker? You want a sucker? Okay. So today we're going to review factoring. And I accidentally, when I made this packet, put the factoring worksheet in twice. I don't know how I did that, but I did because I'm like talented. Yeah, one to everybody. I'm going to scan this really quick. I'll be right back. Hey, does everybody remember how to factor? Oh, good. Oh, and by the way, I do probably want to send around a sheet of paper or take a count because Mr. Adam was asking me over who wants to take 136. Okay, so. Okay, so no matter what, you always look. No matter what, we always look for a greatest common factor first. If it's a binomial, we're going to check to see if we can factor by using difference of two squares. Remember, there is no sum of two squares. It has to actually have a minus. If it is a trinomial, we're going to check our x puzzle, right? Our little x. Other polynomials, if you have four, you could also try grouping. There are some things here about perfect squares. However, perfect squares can also be done by your X puzzle. Remember, for those of you who've done Algebra 2, you do this a lot by reducing rational expressions. For those going into Algebra 2, this is the type of stuff you'll be doing here, where you'd factor and then you'd cancel out the common factors. Over here gave you a little review just in case you forgot how to factor. So right here, we have some problems to do. So what I'm going to do is I'm going to turn off my screen. I don't have the answer key to this. I just found it online. And I'm going to factor, and then we can compare our answers. How about that? Okay. Go ahead, have fun practicing factoring. We are going to need to factor our next geometry lesson. Some of you finished, some of you didn't. The first one is just GCF, right? This one is difference of two squares. This one's also difference of two squares. This one was grouping. Mm-hmm. Where you separate it into two separate ones and then you go ahead and factor again. And please, for those needing to go into Algebra 2, look this over during your extra days off. Very first day, they usually start factoring because you took a break from Algebra 1. I mean, you swapped it out. And Miss Wendy is going to be teaching Algebra 2 next term. You'll be fine. She's a very nice lady. Um, so this one was just the X puzzle, right? Because A is equal to 1. You didn't have to do grouping. Some students will do AC grouping even when you don't need to. I don't understand that, but okay. This one, grouping, you had to multiply 9 times 4, right? And then you had to do your X puzzle. This one was just GCF. Um, Here, this one's GCF. This one's not factorable. I put no factorable. It should be not factorable. This one was AC grouping again. This one was just your X puzzle. If you need a printout of this, I can just print it out. You don't have to take pictures. If you want a printout of this, I can give it to you. Okay. While you are on your break, I'll print it out to make your life easier. Because I'm here for you, team. I am here for you. Okay. Even though Peter says I'm crabbier this term. 6 times 6 is 36. This is AC grouping again. I'm going to print this. So I'm going to print it out for everybody. This one here is AC grouping again. AC grouping. This one's AC grouping. This one has a GCF and then AC grouping. This is just the X puzzle. Yeah, just a big X. This one's also just big X. Hmm. This was unique. This is AC grouping. And this is just plain grouping. Because you had just 4 terms, so that's grouping. This is AC grouping again. This is GCF and big X. No, just big X, not grouping. Just say, because A is less than, is equal to 1. And then this is just GCF. Oh, I'm printing it. Just give me a second. I'm printing it. Yep, there you go. Okay, you can take your break. I'm going to give you a little bit longer break. And then, how come this isn't popping up as printing? There it goes. When you get back, we're going to be applying factoring to geometry. I apologize. Okay. Lines and segments in a circle. Yay! So you're going to understand the use of properties of chords, tangents, and secants as application of triangle similarity. Use properties of circles to solve problems. I'm just going to skip that, and we're going to start looking at the actual theorem. So turns out that in a circle, that if I have two chords where they intersect, if I multiply them together, they should equal the other two little pieces multiplied together. Oh, where did that go? Let me show you. So let me make this bigger. So EA is this piece here, right? Okay. Now EB is the other segment of that same chord. Do you agree with that? If I multiply those two together, it's going to equal the two other segments of these chords that it intersected. So these two multiplied together would have to equal. Okay? Take a minute to look. If you need pencils to mark up your, I have some colored pencils in this bucket here. So let's do an example. So this is 9 for this part. That's AE. EC is X. What do I do with those two? Multiply. So 9 times X is just 9X. Has to equal 3 times 6. So 9X has to equal 18. I divide by 9. X would equal 2. Dun, dun, dun. That's it. It's in your packet. Did you find it? Oh, okay. Come on. You do this one. 9, 18. X has to equal, what is 12 times 9? 108? Divide by 18, and x is equal to 6. Right? That's it. These two pieces here, this one here, see these are the two pieces of this chord? You multiply them. You take these two pieces and you multiply them, set them equal to each other, and then work it out. It's the proportions that are equal because they are chords. It's based upon similar triangles. That if I drew and made triangles, a lot of these theorems actually get into calculus too. It's like to explain the theorem would be higher level math than you currently have, and I'd have to look it up. Okay, shh. Lee, I feel like I'm in traditional high school. Okay, EA multiplied together with EB. Now be careful because that's the whole thing here. Has to equal EC and ED. Okay? I'll try and send you a video of proofs of those if you like, Andrew. If you want me to send you that, I'll try looking it up and send that to you. Now, here's another weird theorem. This one is a tangent segment versus a secant segment. So it's saying that if you square this one, it's going to equal EC times ED. Let's apply them. Okay, so here it says, because I rewrote the theorem here, LM, right, times LN has to equal LO times LP. So here you would get LM is 9, but what's LN? 20. It's 9 plus 11, right? So that'd be 9 times 20. LO is 10. What's LP? 10 plus X. This whole thing here is 10 plus X. So this would be 180. This would be 100 plus 10x. This would be 100 plus 10x. How would I solve this one? Well, you'd subtract 100. You want to isolate variables, not get them just to another side. So then divide by 10. What does x equal? X is equal to 8. You guys try this one. I'm going to do it on a separate sheet of paper here. I don't have the answer. So what do we get for an answer? Boy, we're getting a lot of different answers here. Okay, let's look. It says DE. What's DE? Okay, times what's DF? That's 21. Has to equal 12 x plus 12. So what's 11 times 21? So you subtract 144. So you get 12x is equal to, is it 87? Okay, and divide by 12. I know, but I had a lot of different answers there. So, well, you said 7.25. Man said something else, and then someone else said something else. So that's why I did that. Okay, now we're going to apply this one. CB is the tangent, right? So I'm going to do 24 squared equals CD, which is 12, times 12 plus x. So we get 576 equals 144 plus 12x minus the 144. What is it? 32. Divide by 12. X would equal 36. So this is just applying these formulas, right? Once you just substitute in, you use your algebra skills to figure it out. You try this one. What is it? X equals 5. That would be correct. Did everybody get x equals 5? Okay. Now, these you have to factor. And it's all, with these, it's just going to be your big X's, by the way. So here, this formula says AB times BC has to equal DB times BE. So here you would do 21 times 20 has to equal x plus 2 times 2x plus 6. So, what is 21 times 20? What did you say? 420 has to equal. Now, you have to factor this. So, that would be what? 2x squared, because x times 2x. Then you're going to do x times 6. So 2x squared plus 6x plus 4x plus 12. You need to combine your like terms. So you would get plus 10x plus 12. You're going to factor. Well, I can't do anything till I subtract the 420. Because you have to get it equal to 0 before you can factor. So 0 equals 2x squared plus 10x minus... What? How are you... What are you talking about, plus 2? I'm trying to figure out what... I know, but when I asked that, you kept yelling at me different numbers. Thank you. Oh my goodness. So, first, you always do your GCF first. What number can be divided into all those? So divide all those by 2. Because we're going to be solving, I'm not going to worry about putting the 2 out in front. So I'm going to get 0 equals x squared plus 5x minus 204. Now I'm going to have to play with factors of 204 because if I do big X, this will be negative 204. This will be positive 5. So one set of number we'll have to subtract because this needs to be negative. Let's see. What's half of 204? That'd be 102. And, oh, so 4 can go into that. 12 and 17? There we go. And the 17 would have to be positive. The 12 would be negative because I need a positive. So it'd be x minus 12, x plus 17 equals 0. So what are our two answers? X could equal 12 or x could equal negative 17. Could I use negative 17? Because if I put negative 17 in here, I get a negative 15. Could I have a negative side length? No. I'm going to throw that one out. 12 would have to be the answer. So this would be 14, and this would be 30? Yes. Does that work? Do this for me on a calculator. What's 14 times 30? 420. Okay, what's 21 times 20? Ah, see that did work. So x had to be 12. Yep. So the answer is x is 12. Let's try this one. Now, if it helps, you could label these because sometimes it does help to have a reference. So for these, EA is, what's EA? EA would be 8. What's EB? Which is 18, right? Because I had to add these together. 10 plus 8 equals 18. So what is 8 times 18? Is that what you got? Oh, 144. I was like, boy, that's a big number. Okay, now let's do the other side. What's EC? X plus 4. What's ED? X plus 4 plus x plus 2. Which when I simplify that, that's 2x plus 6. So I'm going to have to multiply x plus 4 and 2x plus 6. So I would get, I'm going to do it over here off to the side, 2x squared, because x times 2x is 2x squared. X times 6 is 6x. 4 times 2x is 8x. And 4 times 6 is 24. I'm going to combine my like terms. So and that'd be 14x. So it'd be 144 is equal to 2x squared plus 14x plus 24. I'm going to subtract 144 on both sides. I get 0 equals 2x squared plus 7x minus 120. Oh, why did I put 7? Because I was thinking about sorry, that was 14x. You're going to divide all that by 2. My brain was working faster than my pen. Does anybody else do that where your brain works faster and then like it automatically? Oh, so wow, I'm running out of room here. I get x squared plus 7x minus 60. Yes? What's 8 plus 6? Okay, x times 2x is 2x squared. X times 6x is 6x. 4 times 2x is 8x. 4 times 6 is 24. When you combine your like terms, you get 14x. Now I have to factor this. And this you would use the big X, right? You get negative 60 up here. You have 7. So two numbers that multiply together get negative 60, but when you add them, get 7. So, and your 12 would be the positive, and your 5 would be the negative, right? And so that would be x plus 12, x minus 5. When you set it equal to 0 and solve, you get x equals negative 12. You get x equals 5. Could I use that negative 12 though? Because negative 12, no. So x is equal to what? 5. We good? You all thought you were done with factoring, didn't you? I know it's all over the place. Gotta write smaller. I was just making it a little bit bigger. Are we done? Okay. Now what about this one? This one, I'll try to write smaller this time. I'm going to go ahead and label. This would be E. This would be A right here because this would be the tangent. And this would be C. And this would be D. Right? So EA squared would be, yep, 12 squared, which is 144, equals, what's EC? Is X. And then what's ED? X plus 10. So I get x squared plus 10x. And I'm going to subtract the 144. Right? To set this equal to 0. I need to use the big X. Oh, you are just with it. Oh my goodness. I can't even finish writing it down. And she's like, got it. That's wonderful. What were the two numbers? 18 and minus 8. And so it'd be X plus 18, X minus 8. And then you'd have X could equal negative 18. That can't happen because that length can't be negative. And then X equals 8. So X would have to equal 8. Okay. I'm not doing anything other than moving.